Hey y'all, been a lot going on. Tina and I both had colds this spring. Been cleaning up around here, trying to make room for a new tractor I bought. Going through a lot of old stuff and trying to get rid of some stuff. Been working on my house in Virginia, so I've been out of state here and there. But back in the shop, getting back on a welding job here. Let's take a look at what we got. This is loader arms for a case loader. It's what she'd look like from the front. You know, your bucket be right here. But what we got, there's obviously a little issue right here. That ain't supposed to be like that. But the good thing is, we got all the parts. Because what we need is one of these. This needs to be back on there. And if it was, it'd be a whole lot more gooder, because it just ain't gonna work the way it is. And they brought me the pin, that's a critical part of this, because the way this loader arm goes together, that pin has to go all the way through here. When this piece gets put back on here, it's got to be positioned so that that pin will go all the way through here. Now, the technique I'll be using to some extent to put this back together is this puzzle piece technique that I use, where, you know, if something's broken off like that, even though you're not able to just see, it's not going to let me position that the way it needs to be, because when it broke, obviously there's parts of it that have misshapen themselves and won't allow me to just stick it back on in the right place. What I'll do though, I'll grind and cut and remove some parts and leave others, so that when I put this up here, it fits back together perfectly like a puzzle. And that gives me at least a place to start on how I'm going to reassemble it. And I'll use that puzzle piece technique. And if you use that technique to put something back together to get it positioned correctly, you can't really bevel it beforehand. I say you can't really bevel it beforehand, but you do have to bevel it. So what I'll be doing is I'll grind, cut, and remove badly deformed pieces, so that that piece puzzle pieces and fits back on here perfectly as I can get it. And then I'll tack it, and then I'll slide the pin through, maybe make some adjustments so that the pin goes through, and then I will back gouge or gouge. I guess it wouldn't be back gouging because I'm doing it from the outside. But I'll gouge this out. I'll be making my bevel by gouging this out when the piece is on there. And then I will weld it up. And a big part of welding this up is getting this straight, so that this pin that goes all the way through both those sets of bushings goes through there freely. Now you can fudge it a little bit. Obviously that fits pretty good the way that's going on there. I just barely had to bop it. So I mean, it's not completely perfect, but it does slide on there decent. Now you can fudge it a little bit, and what I mean is, if you get the alignment of that off a little bit, or your heat distorts it a little bit, this pin could always be put in from this side, and you could sand a little bit off the end of that to make it work. That would be undesirable. Obviously, it'd be nice if you didn't have to do that, but odds are with an older pin like this, it's probably deformed a little bit anyway. So, you know, a little sanding's not going to hurt it. You don't want to take a whole lot off. And another thing you can do in a really severe warpage situation with that pin just absolutely won't go through there at all, you could heat here. You could heat this arm and try to make some sort of adjustment, twisting or whatever there, and hopefully we don't run into a whole lot of trouble with that. I'm sure there's been a lot of scenarios where something like this got welded together and it had to get cut back apart. I've probably even done it myself, although I can't remember a time that happened right now. But, you know, sometimes if that pin won't go through there, it won't work. So that's going to be key, is to getting this lined up so that the pin will go all the way through. So we'll get going on this and get this thing fixed for him. So with that first little light grinding, we've got some areas that fit really good right here. It's coming together. Got some places that don't look so good. That's a little off right there, and it gets more off as I go up. Pretty obvious looking at this other side. This other side's not coming together. So we're gonna have to do a little more here. And I notice when I'm trying to wiggle it, it's moving too much, where it's teetering on parts that still need grinded off. But we're gonna keep going a little at a time and try to get this to come together. You can see where that, you know, where that wants to fit together. And there's just some metal that's preventing it from doing what it needs to do. So I've grinded both sides of this twice now, pretty lightly, and what I'm trying to do is leave that outer rim alone as much as I can, because that's what I'm looking at on my lineup. When I bring this over here and go to hold it where it needs to be, see, I just want it to puzzle piece together like this. And when I push my hand against it and try to wiggle it now, it's not wiggling. It's not setting on anything that's messing up its fit at all. So even looking here at the other side, it's going together pretty good. So I'm gonna hold this up with the pin and push it together, and we'll see what that looks like. Got your basic jack stand extendificationators right here, and it's doing the deal. And what we'll see when we look right here, if I just bring this up, bring it over, and try to push it together, that's as far as this wants to go. And I've still got quite a ways to go to get where it needs to be. So if I look over here at the slack I've got, see, I need it to go that way, and I need it to go more than it's going. But if I just let it go where it wants to, you know, it's come back quite a bit. So the question would be, what's going on with this? I'm suspecting that when that piece broke, this other side got bent some. And the reason I'm saying, one of the reasons I'm saying that this other side bent is probably because when I rotate that pin, it doesn't feel to me like the pin is really badly bent. And I don't think that the other arm being bent would create this issue. So what I feel like needs to happen is this needs to do that just a little. This right here, this assembly, needs to sort of go. And one thing I'm going to try on that, I think what I'll do is I'm going to try to get some shrinkage out of this side right here. And so what I'm going to do is I'm going to clean the paint off of that right around that bushing. I'm going to get my rosebud with my oxyacetylene torch set up, and I'm going to turn my oxygen down to about 15 or 20 and turn the acetylene up to probably 10. And I'm going to heat around that bushing. I'm going to heat the arm, the tube. I'm going to heat that up and cool it off. And what I'm thinking is, if I can get a little bit of shrinkage out of that, then maybe this might pull over on its own and go where I need it to go. If it doesn't, it's not going to hurt anything. You know, there's other options we can do. I'm just going to try that first, because I do think that this arm has probably gotten tweaked a little bit. I've said before that when you heat steel, paint on the steel really becomes a hell of a heat shield, and it doesn't heat correctly. If you're going to heat a spot, you need to get that paint off there. One option is just take a regular grinding wheel and grind the paint off. Now that'll put a lot of marks on your steel, a lot of scratch marks because of a rough grinding wheel, and it'll work, but it's also a kind of an issue because these grinding wheels, they only make contact with a small area. So if you want to grind a lot of paint off, it's a lot of work. Another option for paint removal is either a flap disc or a sanding pad like this. Now that makes more of a contact with a bigger area, so that's a little better than a grinding wheel. What you run into though is paint gums these things up pretty bad. So that's going to get clogged up with paint pretty quick, and that's undesirable. Now, to heat the metal with the rosebud, I say you want the paint out of the way. What I'm going to do before I hook up my rosebud is I'm just going to take my regular cutting tip, and this could be done with the rosebud too, but I'm going to take my regular cutting tip and I'm just going to heat that up, and I'm going to blow oxygen at it and heat it and blow some oxygen, and then I'm going to power brush it when it's hot. Now that won't make any grinding marks or scratch marks on the metal like a grinding wheel will, but it will remove the paint, and the combination of the heat and the power brush is a pretty efficient way to get rid of that paint. So that's how I'm going to do it. Now I want you to see, with that heated, how much bigger of a gap I've got right here now than what I had before I heated it. That's what's going to happen when you use this heating technique. At first, I've heated that metal is expanded on that side, and it's going to go the opposite way of what we actually want it to go. Now, when that cools, it's going to shrink. It's going to shrink a lot. And hopefully it's going to shrink down a little more than it was when we started. And that'll pull this together. But right now, obviously, when I push that as far as I can get it to go, as close as I can get it to go, there's still a bigger gap in it than what there was before I heated that. And what we're looking at now with this is we can see that with virtually no effort at all, I can push this right over where it belongs, right over where it fits good. And when I do that, I can easily, with just my fingers, I can rotate that pin. So we've got to be in decent alignment. I think I'm going to get a Miller-Matic over here and put a couple tacks on this. That's not as cool as it will be, but it's probably cooled down as much as it needs to give us a decent idea of where it's going to be. So I'm looking pretty good here, I think, so far, with some tacks on it. If this was really misaligned, it wouldn't rotate this easy. But if I pull it out, of this side, right there it's a little bit stuck. I'm going to have to use two hands. So by putting two hands on it and pulling it and turning it a little bit, it came right out of there. And if I just kind of get the feel for that, the way it wants to go running straight, it still wants to be a little bit this way. I have to push it that way, sort of, to get it to go. And that means that where I heated that, if that shrinks more than it's shrunk already, then that situation will continue to get even better. And it's still hot. Very hot. So, there's times when it's a decent idea to take a break, and I think right now is one of those times. I'm going to let this cool completely and then see where we're at with this, and maybe go pet a puppy dog or something for just a minute, get a snack, because I'm not just going to keep pumping water to that and make a mess of the place. There's no reason to do that, and I only wanted to cool it with the water quick enough to get something put together here. And as for right now, I'm gonna give that a few minutes and let it cool down, and then see where we're at, because we're close. I mean, we're real close here. As a matter of fact, if it turns out like that in the end, it's better than it needs to be. But I'm pushing that through there just with my one hand and twisting it a little bit. No no lubrication at all. And we'll be lucky to get it that good. But yeah, we're just going to take a break on this, and we'll come back when that other arm's cool and see how it does. This thing's cooling down pretty good. I think it's probably that water is setting on that surface over there. So it's obviously not over 212 degrees, because if that was at boiling temperature, that water would have just slid right off there, like it couldn't even touch it. So that's probably as cool as it's going to get. I put a little bit of tension on this with a mini puller in this direction, and I lift it up, just give it some support underneath. You got to be careful doing that, because you don't want to. I wasn't trying to bend the pin, you know. I was just putting tension on it. This is not really tight. Just put tension on it. So while that's cooling down the rest of the way, and while I'm taking a minute, I'm doing something else. I'm going to address this piece. This is the piece that came out of right here. And I'm going to put it back, but obviously it's got to get shaped so it'll fit in there. And what I'm going to do, I'm going to clean this up. I'm going to tack a piece of steel to it. Give me something to hold on to. I'll tack that piece of steel on there, and that way I can grind this and try it in there and get it fitting the way it needs to be. So with that tacked up in the position it is right now, and this thing sliding in and out that good, what I'm going to be doing, I'm going to get that out of the way, and I'm going to do my gouging. I've got these tacks here, which will obviously have to be completely gouged out, but not until I get some other better tacks in there, and I can't get those in there until I do the gouging. Now, on a lot of heavy equipment, I would normally go right into this with a carbon arc. Considering how thick this is, or thin for that matter, I don't think I'm going to carbon arc. I'm going to get out old Big Daddy 9-inch grinder and just go into it with that. And I don't think it's going to take me long doing it with a grinder. I may be wrong. You could definitely carbon arc this if you wanted to, but I just think I'm going to be able to, we're not talking about a lot of thickness of material here, and I think I'm going to be able to go right into there with a grinder and get the kind of penetration that I need on it without it taking too long. So that's up next. Let's do it. So let's see what we look like here before we start welding. I know you probably seen me dabbing on it with that MIG welder, with that solid wire MIG, and I just what I was doing with that, I was skipping around and putting weld back in the places where I had grinded clear through or grinded too deep, and the places that were pretty good, I just ran a quick pass down over them that I could grind out. And most of that MIG weld that I put in there is actually deeper or pretty much level with the inside surface of this thing. And I don't want you to think that you could not weld this out with a MIG welder. You definitely could. I could take that Miller-Matic right there and I could weld this up and it would probably be fine. And if this was a repair that you were making on something that belonged to you and your solid wire MIG was all you had, that would be a great option to weld it up. Now I'm going to stick weld this. You'll see some places like right here, there's some porosity where I'd run that MIG. And it's hard to not have some of that in a situation like this, because while I'm welding on this closed tube, the heat is creating pressure inside of there and there's air trying to come out, which is, disrupting the weld and disrupting the flow of the gas. And I'm going to stick weld this simply because stick welding's better. Like I say, you could definitely weld this up with a solid wire MIG and it would do good. A MIG welder is a low hydrogen, but it just doesn't offer the elasticity that you get from stick welding with a 7018. So I'll talk for a second how I'm going to weld this up. I'm not going to start out with a 7018. I will finish up with a 7018. I'm going to run a first pass with a 5P plus pipe rod. Probably 5/32 diameter. And when I'm doing that, I don't want to deposit a lot of weld. I don't want to fill it up with that rod. What I'm going to be doing with that rod is I'm going to be basically just hot passing in a way that I'm testing that surface and creating a surface for me to weld 7018 on. And I'll tell you why I like to do that. If I was to go into this welding with a 7018 right now and there's a place that's thin, well, we know there's places that's thin. We found porosity in my MIG. If you're running a 3/32 7018 uphill and you hit that porosity and you blow a big hole in it, it's going to be hard to fix that spot and make a nice weld compared to running around that with that 532 5P plus and getting a solid pass in there that is very thin but creates the shape and stability back there to run the 7018 on. So I can dance around that fast with the 532 5P plus and then go back with either a 332 or a 1/8 inch 7018. And with that rod, then then once I've got to pass a 5P in there, when I go in with my 7018, I'll really be welding and I'll really be trying to fill it with material then. With the 5P, I don't want to fill it with material. I just want to burn the trash out of there, make a good seal on it, and create a surface to weld on. So now we're going to go into that part of it. I'll be using the XMT 304 Miller inverter on that, and I'll go get some rods and we'll get set up and we'll get going on that welding. So I ran a pass around this with my 5/32 5P plus pipe rod. And I use this rod because deep into the penetration, deep into this weld, I want to have a lot of control with a lot of heat. If I was doing this with a 7018, I would not be able to have a lot of heat and a tremendous amount of control like I do with this rod. So what I'm talking about here is I was running that machine on 165 amps with a good size rod. This is a 5/32 rod. I have a lot of metal here. What I'm doing in a hot pass scenario with this is I'm checking my arc length by making sure that my rod is making contact with the base metal. And then I scratch. And then I pause. And as I pause, that puddle will swell. And I want it to swell until it's just a little bit wider than the last pass underneath it. And then I scratch. And then I pause. And I let it swell until it's just a little bit wider than the pass underneath of it. Now, the way I get a tremendous amount of heat control with this pipe rod is when I lay this rod down and scratch like this, it blows a lot of the heat forward somewhat. If I start out like this, I have a tremendous amount of amps on the rod, and I start out with this rod on this steep angle. When I see that I need more heat into the metal, all I got to do is change the angle of the rod. And if I get to the point where I'm holding the rod 90 degrees from the material, then the penetration is extremely deep. Now, all the way down this side, I just pretty much got a standard hot pass, scratch and pause, scratch and pause. Now over here, this side, the MIG weld that I had under it must have been a little bit weak, because as soon as I began to scratch and pause, I blew right through there. So when I blew through there, it was time to go into a root bead mode, not a hot pass mode. So I didn't scratch and pause any longer. I just press and move. And as I pressed and moved, I made this bead. Now this is very much like a root bead. You see, this weld over here is more of a concave weld, a cup-shaped weld. This is ready to, this is ready to weld on. This root bead over here, if you look at each side of that, you'll see there's spots here, real deep areas. These are wagon tracks, and there's slag stuck in there. And that's a situation created by that root bead that had to be put in there to fill this up. Now, if I would have went on scratching after I blew through this, I would have just blown this completely out. Once I blew a hole through it, I knew I had to go into a root bead mode and travel quickly and manage my heat with my rod angle. If I needed more heat, I would raise up. If I needed less heat, I would lay down. And I ended up with this root bead. So you don't want to try to weld over this without grinding. You could, and a lot of guys, especially skilled pipe welders, they can hot pass over this and burn all those wagon tracks out. I'm not gonna. I'm gonna take a grinder and I'm gonna remove this hump. That hump in the center of that, I want to knock that down. And then I'm gonna hot pass. I'm probably just gonna run another pass of pipe rod around all of it real quick here. And then I can go to my 7018 and really start welding. So what the pipe rods allowed me to do is to run these 2 passes on here and get this thing solidified and ready to weld up without depositing too much metal. It'd be really difficult for me to have done that with the 7018, to run 2 passes and still not be full of weld. And this wasn't ready to fill full of weld. The way that I gouged it out, I want this surface that I have right here, this is like a very deep concave surface that's ready for me to weld up and put in the high quality 7018 weld. Now on the, I realized there before when I was grinding, I didn't really mention why I was grinding, but if you look at all the corners are where I have starts and stops. And your starts are always going to leave a lump. And that lump should be grinded off. If you have a bump like that right there, that bump from that start. See, at the edge of that bump, there's a place that if there's slag there, it's going to be hard for you to burn that out because it's deep. It's clear in under that bump. So when I grind those bumps from a lumpy start or from anything that's lumpy, what I'm trying to do is I would grind that in a way that I'm kind of trying to make a ramp instead of a cliff where we could have slag stuck at the bottom of the cliff. I'm trying to make a ramp so that when I'm transitioning from this weld on the side to the weld on the top, that it's a smooth transition without any deep places where slag can remain. Well, let's take a look at this first pass to 7018 we got in here. One pass to 7018 over top of the 2 passes of the pipe rod. And some of the things that I like to mention about running the 7018 uphill like this, when you manipulate your rod in a situation, see this part of this weld right here is kind of like you're moving up on a 45-degree angle almost, making this weld. But when you do that, you still need to carry that weld level. your steps and your motions need to be level. And I say that, and it helps people a lot when I give that tip, but you got to think about what's happening there is you move and you make a level, you deposit material in this level manner. And as you progress upward, depositing the material in this level manner, what's happening is that material that's cooling behind you is creating a bridge for your weld to set on. That's what prevents you from having these terrible sags. And a lot of new welders have these terrible sags with 7018, and they wonder why. There's a few things you got to do. You got to carry that material level, okay? And you've got to set your amperage correctly. And if your amperage is set correctly, especially in the vertical position, then you're going to have to run a little bit of a long arc to get it going. Remember, as we weld, especially with our stick, as we weld, we can manage the heat a little bit with our arc length. The longer the arc, the more heat. The shorter the arc, the less heat. So on these vertical welds, if our heat's set correctly, you're going to start out with a bit of a long arc to get it going. And if I'm going to start welding right here, I'll actually light that rod up maybe clear over here. And I'll long arc that rod and let that thing get hot. And then I'll come down and begin welding. I'm going to make my steps in a level manner. And as I continue up through here, I'm going to start pressing the rod in more and running a shorter and shorter arc as the material heats up. And that's to cool it down so it doesn't get so hot and drip. Now, if you look over here where this has been run pretty narrow, this is almost a stringer bead. And people get those drips with their stringer beads with 7018, and they also get stringer beads that are humped way out in the center, which are, you know, those are both situations that are bad. The same thing sort of applies as far as your step. Even when you're going pretty narrow in the sense of almost a stringer bead, but you still need to manipulate your rod in a level way, and you still need to force that heat to go left and right. Now, when you're running a stringer bead or a very narrow weld, that may actually be changing your angle. Like right here, I'm projecting heat to the right. Now I'm projecting heat to the left. Now, obviously, I'm exaggerating, but the idea that I'm trying to show you is, even when you're making a narrow vertical weld with 7018, you need to project heat to the left by pointing the rod a little to the left, then to the right, then to the left, then to the right, then to the left. And what's going to happen is you're going to stay level. You're going to put that heat to the left, and while you're putting that heat to the left, this material over to the right is cooling down a little bit, so that when you come back over here, it's not so hot and drippy. So even when you're not making a motion where, you know, it's a wide weld, even when it's a stringer bead, a motion like this where you're not really moving the tip of the rod as much as you're just projecting the heat by angling the rod, that will help you to keep from having those drips. And I call them gonzos. Whenever you get the big drip that sticks out, looks like Gonzo's nose. So we're ready to put another pass on this thing. It's possible that one more pass could do it, but I'm going to have to deposit a lot of material. And in order to deposit a lot of material, I'll be turning the amps down. I ran this at 80, or actually I think 83. So here I was with a 332 7018, I was at 83 amps. And the only place that I think is going to take more than one more pass to make it work is probably going to be down here on the bottom. and especially where I have this this piece that I added in, and there's like this fork that has to come together. It's going to take, this is probably going to be like a stringer, another stringer, another stringer, and I'll just have to keep stringer beading this until I cover this entire area up. So we'll get that taken care of now, and let's see if I can fill this up with one more pass. I'm going to turn it down a little bit. It'll take a few rods because I'll really be pushing them in there, but we're looking good, so let's keep going. All right, then we're gonna have us a look-see here at this final pass of 7018. This is the side come out quite a bit wider. But it filled up, it's good. Yeah, that's fine. Now, I did notice when I looked at this other side, there's a few things I'm not crazy about on the factory weld. If you look here in some of these places, right here is a place where I can still see the edge of that, where they didn't even weld over, which, you know, the factory, you know, generally it's it's strong enough, you know, when they do it generally. And obviously this isn't the side that broke, so it was good enough. But right now, since I've got it in here and I'm welding on it, something like this is an area that is really underfilled. And you know, I'm not going to go crazy and waste a lot of time, but I'm going to fill that in. And I'm not crazy about this right here either. There's a few areas, just little spots where I'm going to weld over it. Like I say, I'm not going to go crazy, but I'm just going to fix on it a little bit there, and everything else with this, I think, is good on this side. So we'll do it. We'll put a little weld there where it's shy, and then we're going to have to let this thing cool completely down and see how our pin goes in, and see if we need to do anything else for that. So just run some passes on those places that I didn't like, and that's good. There's about, I don't know, 3 places there I wanted to run a little bit. And something I want to mention about that, I don't know if you noticed, but when I was welding this other side where there was a lot of welding to do, there were several times I'd have a half a rod or a little more than half a rod whenever I stopped. And whenever I stopped and I had that piece of rod, I would set it on the vise. I've been working at places before whenever I would set a rod down like that, or I'd throw a half a rod in a bucket, in my bucket. When I'm out in the field, I always carry a bucket. And people would say, why don't you use that? You're wasting welding rods. And I'm like, how do you know I'm not going to use it? Just because I'm not using it right now doesn't mean I'm not going to use it. If I'm about to start welding and I'm going to run a weld where I know I can use a whole rod, I'm going to get a new rod. And I might set that piece of rod, that half a rod or whatever that's in the stinger at the time, I might set it on the vise, set it on the table, toss it in the bucket. That doesn't mean I'm not going to pick it up and use it. I'm not going to start out with a half a rod if I know I'm about to be in a position where I can burn a whole rod. Now, the reason I guess I'm mentioning that now is every one of those little repairs that I made right there was made with those pieces of rods that was left over that I laid down when I was welding on that other part. But I knew that, you know, I'm trying to go 1 inch or 1 1/4 inches. I didn't need a whole rod. So that's just something I'm going to mention, because I've been out in the field a lot of times and I'd throw a half a rod or 3/4 of a rod in a bucket and get a new one, and people were like, well, what are you wasting that? Why don't you use that? Well, I do use that, but I'm not going to take off in a position where I know I can use a whole rod with a half a rod. I don't do that. So what we've got to do now is we've got to test this pin, but this thing needs to be completely cool on both sides before we do that. And this is part of it that could take some time, because if I let this thing completely cool to where I can hold my hand on it on both sides, and this pin doesn't go through there okay, then I might have to heat and do something, you know, and sometimes it takes a little time. But there's a few places I'm going to buff up on here, maybe hit her with a sanding pad here or there, get rid of a dingleberry, and I'll probably just get a snack or something and give this thing time to cool down, and then we'll test that pin and see how we get. All right, y'all. Well, you know, starting this out to get this lined up, you got to see I did a bit of a heat treatment on this to move this tube, and
you know, remember how that works. If I heat that tube on this side, that thing's going to go like that because it's expanded this side of the tube. But when it cools, it should come back more than it originally was. So if you want this to go that way, you're going to heat it here, but don't freak out when it does this at first, because it's going to do this from the heat where you heated it on this side. Then as it cools down, it should come back. You'll have to you'll see the color of the material when you heat it. When it goes from red to bright red to orange, you're around the bright red to orange area, you're gonna be getting it to about probably 1500 or 1600 degrees, and that's about the minimum to actually make anything happen. Now, obviously, the wider of an area that you heat, the more expansion and contraction you're going to get. Well, I know somebody's going to say, well, how do I know how much to heat it? Well, do it for a long time. Do it several times. Experiment with it. Practice it. Work with people that have done it. I can't really tell you how much to heat it. But if I look at it, I got an idea how much heat I'd want to put on that to get it to move the amount. It's experience. It's just experience. And it pays to have some experience with it, because the less you heat it, the better. Which is something, you know, especially true on equipment, because you're never working with mild steel. This bushing's not mild steel. It's harder and stronger than that. This arm is not mild steel. It's probably made of something more resilient, a higher tensile strength type material. Welding this up after I grinded it out and got it the way I wanted it, you know, I ran them first couple passes with the 5P Plus, the 6010, the pipe rod. That's something I like to do. Not everybody does. But I can run a couple passes quick around something with the pipe rod, and I can make a clean, deep penetrating weld that doesn't overfill the material. I'm getting it ready to weld. I'm not trying to weld it up with that. I want to weld it up with a 7018, but I want a good surface to weld on with that 7018. Like I said, if I'm running a quick pass around here with pipe rod and I blow through it, that's fine. If I'm running a heavy bead uphill with my 7018 and I blow a hole in it, that's not fine. I don't want that to happen. When I'm running my 7018, I don't want that to happen. I want to be welding onto a good surface that's been solidified and ready to accept what I'm doing to it. So I like to put a couple passes of 6010. I call it 5P Plus or pipe rod. I like to put a couple passes of that in something to begin with, and then I finish up with a 7018. Another good option would be a dual shield wire. That's like a flux core wire with gas. You can also use flux core. You can also use solid wire MIG. 7018 is always going to give you the most resilience, the most elasticity. A 7018 is always the best for welding dissimilar metals. Remember, I was just talking about, this isn't mild steel. Equipment is built generally out of materials that are stronger than mild steel. They have higher tensile strength, and when I say dissimilar metals, I'm talking about this steel that this arm is made out of is probably different than this bushing is made out of. And you run into that with equipment all the time. The steel that the cutting edge of a loader is made out of is much harder than the steel that the bucket itself that you're welding it to is made out of. But yet, all of it is stronger generally than mild steel. And those dissimilar metals are always very well welded with 7018. So it's a guaranteed good choice, you know, when you're not sure what you've got. If you're just welding mild steel, it doesn't matter as much. You don't necessarily need a 7018. You can use just about whatever, and you may not need that real flexibility that's given to you by welding with a 7018. So just some stuff. We got this fixed. You know, they got a quote on a new one of these when this broke, and it's outrageous. So this is something worth fixing. You know, we fix it up, they'll get a lot more life out of it. And as much as a new one costs, even if it breaks again, it's worth fixing again. So that's it for this. And I know you want to see if it's straight. You want to see if the pin goes through it. All right. They want it any better than that, they're going to have to get somebody else to do it. Thank y'all for watching.